Alright, dude, I'll try to be quick. So you're returning J for number 3. It's given that J is equal to X to the Y. While I is not equal to Y, do something. So that means you can throw the I where the Y was. So that's the loop invariant. J equals X to the I. Case 1 is n is 0. For the first case, all you're really doing is looking at the initialized variables. So you can have this same formula with just the index. J0 equals X to the I0. J0 equals X to the I0. Well, what's J0? J0 given in the code is X. So J is initialized at X. I is initialized at 1. So you have X equals X to the 1. You just plug those straight in. X equals X. So that's good. So now you know those formula. Same from here. J0 equals X I0. We just proved that. So J to the K is equal to X I to the K. All you're doing is just throwing a little index. So that's now known. So now you need to prove for K plus 1. So same formula, just throw the K plus 1 as the index. So J K plus 1 is equal to X I K plus 1. JK plus 1 is your new J. So when you see the JK plus 1, you need to go back to the code and then figure out what the new J is. Well, new J in the loop was J equals J times X, which is the same as the new J is equal to the old J times X. J equals J times X. New equals old times X. So you can rewrite the new equals old times X. Well, now we have something that equals JK up here, the known case. JK is equal to this garbage. So you substitute the old garbage for the old J. So now you have the old J is X to the IK times X. So then X to the IK times another X is just the same thing plus 1. You're just adding one more X to it. So X to the IK plus 1. Now for the right side you have to do something similar because this is the new I. I do it I think on the third step. So you have X to the I K plus 1 is the new I. So then you have to go back to your code, which is here. So from the code, new I is equal to old I plus 1. So new I is equal to old I plus 1. New I is equal to X to the old I plus the number 1. X to the IK plus 1, X to the IK plus 1. The hardest thing is just break down the left side. So you have this new J. Well, what's the new J? The new J is from the code. J equals J times X. New equals old times X. New equals old times X. Well, what's the old J? Well, we proved the old J up here. So we're going to substitute this in, X to the IK, for the old J. Now everything's about the same, and you really don't have to do too much math, except on number 11. I think you have to factor some out, but it wasn't too bad. Once you see where all the pieces are coming from, so your new J. The hardest thing for me to see was when you see this new J K plus 1, that's your new J. And then you have to look to the code to see what J is doing. So new J is old J times X. Old J times X. Old J is given. Plug that in. And then start simplifying a little bit.